This lesson is going to be over problem solving as we prepare to take our STAR tests. The standard we're going to be looking at is 6.8. You will be able to select and use appropriate units, tools, or formulas to measure and to solve problems involving length, including perimeter, area, time, temperature, volume, and weight. Before we jump into some examples, let's be sure we all remember some basic terms that we've either learned this year or learned before, so what we can really focus on is the problem solving and not the formulas we're using. The first one we're going to look at is perimeter. Perimeter is defined as the distance around any closed geometric figure. The formula is just the sum of all sides. So for a rectangle like this, you would add side 1, 2, 3, and 4. All 4 sides together give you the perimeter. Area is the number of square units needed to cover the surface enclosed by a geometric figure. The formula is length times width. So with perimeter, we just want to know how much distance there is around an object. With area, we want to know how much space is covered by an object. We want to know the length and the width and everything in between. With volume, our next term, we want to know the length, the width, and the height. So we want to know everything that this object can hold, how much its capacity is. The definition of volume is the amount of space a three-dimensional figure contains, expressed in cubic units. Our formula is simply length times width times height. Time, we're not going to define. Everybody knows what time is. Just remember, when you add and subtract time, be careful with your units. There's 60 seconds in 1 minute, 60 minutes in 1 hour. A ratio is a comparison of two quantities by division. The ratio of 2 to 3, for example, can be written as 2 out of 3, 2:3, or 2/3. Now, for problem solving, there's lots of different ways you can think through a problem, and lots of times the problem itself gives you a whole lot of information. But if you're stuck, it might be helpful to have 4 things to remember. So we're going to learn the 4-step process. The first step is to understand the problem. There's lots of different ways you can understand the problem, but some ways that are most helpful are to make a table or chart, make a model, act it out, draw a picture, look for a pattern, or solve a simpler problem. The second step is to devise a plan. Here you want to know for sure what the problem is asking. Once you know what the problem is asking, based off help from clues in the problem and the picture or chart you made when you tried to understand the problem, you want to know what formulas and units you're going to be using to find the answer and what your tools or manipulatives are going to be to help you work through the problem. The third step is to carry out your plan that you just made. As you're doing this, show all your work. If you run into a problem, it's easier to figure out where if you write out each step. And then at the end, step 4, check your work. Does your answer make sense? Is it likely to be accurate? Once you've looked over your work, compare it to the answers on the STAR test. Be sure that the answer you found matches an answer offered in the test question. Let's look at our first problem. Example 1. The figure below is a scaled drawing of a design on a gym wall. Use the ruler provided in your STAR handout to measure the dimensions of the figure to the nearest inch. Each inch on the scale drawing represents feet of the actual design on the gym wall. Which of the following is closest to the perimeter of the actual design on the gym wall? Where do we start? Look at your 4-step process. Step 1 is to understand. Now, considering the problem, it's already helped us understand. It gave us a picture. We don't need to draw anything. All we need to do is look at the problem and find out what they're asking. So we're going to go right to step 2, devise a plan. As you read the problem, the very last sentence asks exactly what they want to know. Which of the following is closest to the perimeter of the actual design on the gym wall? We're looking for perimeter, the sum of all sides. Now that we have our formula, what tool will we need to use in order to find the perimeter? The problem tells us this also. It says to use a ruler to measure the dimensions of the figure to the nearest inch. So, do you use centimeter or inch ruler? We're going to use the inch ruler. Do we need any manipulatives or tools other than a ruler? You can use your calculator to add up all the sides, but the dimensions are small enough that you can probably do it in your head also. So, look at your 4-step process. We've understood the problem, and we've started devising a plan. Are there any other formulas we'll need? We'll eventually need scale, because that's our ratio of inches to feet. Read the problem again. Each inch on the scale drawing represents feet of the actual design on the gym wall. So, for every inch we find in the perimeter, the design is 2 feet for each inch on the wall. Now that we have every formula we need and all our tools, let's go to step 3, carry out the plan and show your work. So you might write your formula first. Perimeter equals the sum of all sides. Count the sides. 1, 2, 3, 4, 5, 6 sides. So, the first side is 4 inches. Just take your ruler and measure each side. The next side is 1 1/4 inch. The third side is 1 inch. The fourth side is 2 1/4. The fifth side is 2 inches, and the last side is 1 1/2 inch. Now, add them all together. You might add fractions first. 1/4 and 1/4 is 2/4 or 1/2. Add the last 1/2 to that, and you have a whole 1. Now add all the whole numbers. 4 and 1 is 5, plus 1 is 6, plus 2 is 8, plus 2 is 10, plus 1 is 11. Now add our 1 and 11, and we have 12 inches for the perimeter on the drawing on our sheet. Is that our final answer? Look at the problem. It asks for the closest to the perimeter of the actual design on the gym wall. Our actual design is in feet. Our scaled ratio is for every 1 inch, there's actually 2 feet of border. So we have our ratio of 1 to 2. If we have 12 inches, how many feet do we have? One simple way of doing this is realizing that we multiplied 1 by 12 to get our inch ratio for our actual ratio. So what do we need to multiply 2 by in order to find how many feet the actual design is? Well, just like a normal equation, what you do to one side, you must do to the other. So we're going to multiply 2 by 12, and our answer is 24 feet. Look at the 4-step process. We've understood the problem, devised the plan, carried out the plan, and now we need to check our work. Look at the question. The answer options given are A, 11 feet, B, 24 feet, C, 12 feet, and D, 22 feet. Answer B is the correct answer that matches what we found, the answer to B. You just solved your first problem using the 4-step process. Let's look at the next example. Manuel is getting pet fish, but first he must fill the aquarium tank with water. The tank measures 2 feet in length, 1 foot in width, and 2 feet in height. How much water will Manuel need? Let's look at our 4-step process again. Step 1 is understand the problem. What methods do we have that will help us understand this problem? We need to know what it's asking. Let's draw a picture of the water tank. Because we want to know what is the capacity of water this tank can hold. Now let's go to step 2, devise a plan. We want to know the capacity of the tank. Look at your capacity formulas. The problem gives us dimensions of length, width, and height. Which capacity formula has all 3 of these dimensions? We're going to find the volume formula. Volume equals length times width times height. The dimensions given in the problem are 2 feet in length, 1 foot wide, 2 feet high. Let's draw those on our picture. 2 feet long, 1 foot wide, 2 feet high. Now let's look at our plan. Our formula to find the volume is the length times width times height. So we're just going to go ahead and multiply 2 times 1 times 2. Use your calculator or your mental math and find the solution. 2 times 1 times 2 equals 4. Since we multiplied feet 3 times, our answer is in cubic feet. Is that what our problem is looking for, though? No. What else do we need to know from this problem? We need to know how many gallons a tank will hold per cubic feet. We're going to need to use our ratio. The ratio they gave us was 1 cubic foot is equivalent to 2 gallons of water. So, if our units of water are twice what our units of feet are, we can multiply our feet by 2 to find how many gallons of water this tank holds. So 4 times 2 equals 8. This tank holds 8 gallons of water. Now on this problem, we didn't follow the 4-step rule exactly. Sometimes it's helpful to plan your problem and work through your problem as you're planning it. We got a partial answer of 4 feet, but then we had to go back and plan another way to find our ratio. So we found a way to understand the problem by drawing a picture. We planned out volume, went to step 3 of working the problem, and then had to go back to planning to find our ratio, and we worked to the end of the problem. Now, are we done? There's 1 step left. Check your work. The problem gives us possible solutions of A, 4 gallons, B, 2 gallons, C, 8 gallons, and D, 6 gallons. The correct answer is C, which also matches the answer that we found. Good work! Let's look at our final problem. Example 3. Samantha and Jerome want to play in their pool, but are only allowed to if the temperature is 75 degrees or warmer. At 1 o'clock, it was 67 degrees outside. The temperature has raised 2 degrees every 30 minutes. If it is now 1:30, when will it be warm enough for Samantha and Jerome to swim? Our 4-step process wants us to understand the problem before we begin working. A picture isn't very helpful in this situation. Let's try making a chart. We can do another T-chart with time on the left and temperature on the right. You might notice that this also looks a little bit like our ratio formula. Since the problem gives us a scale, we may need that one too. Let's go ahead and write it down in case. Our ratio was 30 minutes for every 2 degrees temperature increase. Now let's go to step 2, devise a plan. We're understanding the problem by making a time and temperature chart. Now, what else will we need to solve the problem? We're going to need to fill in what time it was when we noticed the temperature first, what the temperature was, and what temperature we need to reach. So, if we use our ratio and increase by 30 minutes and 2 degrees on every line of our chart, we will eventually reach our answer. Let's carry out that plan now. Our start time was 1 o'clock, and our temperature at 1 o'clock was 67 degrees. Our ratio says that every 30 minutes, the temperature raised by 2 degrees. So let's add 30-minute increments and 2-degree increments to each side. Increasing the time, 1 o'clock, by 30 minutes, we arrive at 1:30, the time it is now. Adding 2 degrees to 67 degrees gives us 69 degrees. Is it warm enough for Samantha and Jerome to play in the pool? Not yet. Let's add 30 minutes again. At 2 o'clock, adding 2 degrees, it was 71 degrees outside. We're still not warm enough. Let's add 30 minutes again. At 2:30, adding 2 degrees, it was 73 degrees outside. We're getting closer. Let's see if we can get there in one more addition of 30 minutes. 3 o'clock, we'll also need to add 2 more degrees. It was 75 degrees outside. That's the temperature at which Samantha and Jerome are allowed to play in the pool. The time we found was 3 o'clock. Are we done? There's one more step. Look at the answers and check your work. The problem gives us possible answer choices of A, 2 o'clock, B, 2:30, C, 3 o'clock, and D, 3:30. The answer C, 3 o'clock, matches our answer of 3 o'clock. You've solved the problem using the 4-step method. Good work! Today we have solved problems by selecting appropriate units, tools, and formulas to measure and solve problems with length, area, time, temperature, volume, and weight. To finish practicing and make sure you really understand, do the independent practice problems at home and bring them to class. Replay this lesson if you have any questions as you're doing the independent practice.